Alright, here's Lab 2 presentation for the lab team of Ryan Ness, myself, Mike Jones on the camera, and Heath Kocan out canoeing. Alright, here's our schematic of our audio amplifier for Lab 2, and here's the final product. We'll go through a brief description of the circuit, and then we will have a little demonstration. So the audio input comes in through a capacitor to eliminate like a speaker thump,
DC thump.
like a DC thump, and it goes into a non-inverting amplifier which has the output and the negative terminal connect to a potentiometer to control the gain on the amplifier, and that feeds into a difference amplifier which amplifies the difference between this voltage and this voltage.
Alright.
And Mike will go over the next part of the circuit.
Hi, Mr. Edmondson. Okay, so here's the difference amp. As Ryan said, that's the gain of the amp, audio amp itself. So the output of this difference amp, coming from here to here, this is our output stage. So we have an NPN transistor and a PNP to get as close as we can to Class B operation. These transistors are biased as close to being switched on as possible with these two diodes. So we have approximately a 1.4 volt drop here, which helps to reduce the crossover distortion that you would encounter without it. So this resistor and this resistor here give the quiescent current to this diode, to these two diodes to bias them. These little caps here at low signal levels keep the voltage across these two nodes as close to 1.4 as possible. Okay, so coming out we have, these are our two emitter resistors. They're very low, about 1 ohms. Basically they just keep these two transistors from cooking, thermal runaway and all that business. So they're about 1 ohm apiece. Okay, so then coming to the output of this, the output of this is fed back through a feedback network back to the non-inverting terminal, or the inverting terminal of the difference amplifier. This was placed here, as the feedback network was placed here with this cap to roll off at about, I think, 15K. These are really tiny speakers, so they act as filters themselves. The more you can filter out frequencies that they can't reproduce, the better it's going to sound. So that's why that's there. This represents the impedance of our speaker. We're using a closed switch audio jack, and then we have this voltage divider network that acts to raise the output impedance of the output of the audio amplifier. So when you put headphones into it, two things happen. A, it disconnects the speaker, and B, sends the audio to the headphones, and this raising the output impedance gives you two things. You don't blow your eardrums or your headphones out. So that's it in a nutshell as far as what this thing does. Very small, 2 op amps, a couple diodes, and a couple transistors. It's very simple to build, and we're surprised how well it works. So now we're going to give you a demonstration. Here's our little iPod. Let's see. Seem like the kind of guy that might be into old soul music. I don't know. We'll find out. Volume knob.
Headphones.
Headphones. Now we'll show you how this happens. And it is monophonic, 60s style. And there's your headphone output coming out of the left.
Yeah.
So if you're into retro this audio amp is just for you. And audio back.
Alright, with that concludes Lab 2.